the time our next affiliate, the Korean Desalination Plant Association, who is represented for his former president and IDA director, the Professor Ineskin. Professor Ineskin.
Morning. I'm happy to be here on behalf of present Korea Diesel Plant Associations. My name is In Kim. I am past president of KDPA. Now, the time for us is allowed about an hour. It's 9:40. So we are trying to conclude 10:40 now. I've been president in the past, and we elected new president of KDPA, whose name is Mr. Taehyun Park. He is vice president of K-Water. Now he's supposed to come, but since there is some governmental meetings there, he couldn't make it. So I will try to serve it of this mediating. Now, we have approximately 25 industry members of KDPA and individual members, such as some of the multinational firms, Doosan Heavy Industry, and Hyundai, ENC, LG, GS, POSCO, and with a medium size of the company, and those are very active. Probably you know, Korea is now quite small land area, is a little bit populated, very poor natural resources. The only thing we can get is very high level of education, and it's kind of brain human powers. So we're trying to invest quite a bit of technology development and try to export and increase the business activities in there. Well, in this forum, we have 4 presentations by each different company. Now, everybody please be aware, this is silent session. You have to use earset, and whenever you talk, please utilize the microphone so that everybody can listen clearly. Now, I'd like to invite the first speaker, who is Dr. Kwang Hee-shin from Doosan Heavy Industry and Constructions. And you are allowed about 10 minutes, so probably we can entertain by having a conversations later on after 4 presentations. It's better to share some of the information. Let us welcome Dr. Shin.
Yeah, good morning, everyone. And I'd like to express many thanks to the KDPA and IDA for providing us this opportunity. Okay, so as you know, nowadays all of the business sectors are undergoing digitalization. So we, Doosan, also initiated our digital innovations from 2013 across all of our business sectors to be more efficient internally and to provide more benefits to the customers. Today, I will briefly talk about our digital solutions developed for seawater desalination plant. Okay, so before that, I will briefly introduce our company and water business first. Actually, the Doosan, our vision is to be global leader in power and water. So since 2001, we actively expand our overseas business so that now we have more number of global staffs and actually more revenue came from the overseas business. These are the products. As you know, we have built the many desalination plants in worldwide, and also we are active player in power sector, covering the conventional power plant and nuclear and renewables. And we are also the original equipment manufacturers for key equipment in power sectors. So recently we developed the H-class gas turbine with capacity 280 megawatt. And also we have the several lines of model of wind turbine. And Doosan has three different business groups. One is plant EPC and power service and nuclear. And seawater desalination fall under the plant EPC. We have 11 overseas subsidiaries in worldwide and 7 R&D centers. Actually, I am working in R&D center in Saudi Arabia. So our key equipments for our business are manufactured on our workshop in Korea, Vietnam, India, and Czech. So far, we carried out more than 330 global projects with 180 gigawatt of power generation and 1,600 MISD desalination in Europe and here in Middle East and India and America. Most of the desalination projects were executed in Middle East. So currently our ongoing projects are shown in red in Kuwait, Doha, and Saudi Arabia, Shuaiba, Yanbu, and Oman, Sharqiya. These are our O&M, the reference. We will also do the O&M for Kuwait, Doha, and Oman, Sharqiya project. So, okay, from here I will talk about our digital solutions for desalination plant. We have the Doosan Water Supervision System called DWSS. This provides the real-time monitoring of several SWRO plants in order to provide the stable operation and the plant lifetime extension and higher the plant efficiency. Throughout these platforms, important O&M decisions can be made by the cooperations between the field manager and the technical expert in a central location. This DWSS also contains our know-how for the O&M and technical support record, and also the new technologies. So we keep updating our know-how for the O&M, such as chemical dosing and pretreatment operation and outer membrane the maintenance. And also the historical technical support record made by the design team and the R&D teams also recorded in the DWSS systems. And in addition, for the automatic O&M decisions, we developed the new process-specific digital applications, and they are also incorporated in the DWSS system. This is the structure of DWSS. This system management controls the accessibility and security. It has data management modules. This organizes various data from the field operations. And also the operation and maintenance related data is recorded. And based on that, we compile the several O&M guide. And there's one module for data analysis for further optimization and troubleshootings. And these digital applications provide the automatic and process-specific solutions. This is how it works. So data from the individual DCS are transferred securely by the network system we developed. It's called Argos. And this RMS system displays the data and further process the data that could be appropriate for these each digital applications. The result from digital applications are shared with the users by user interface so that operators can use the result for the O&M decisions. This is about the Argo systems for easy connection and safe data transfer. And Argo supports various types of network, even in mobile. And this is a remote monitoring system, so our center in the headquarters in Korea. Okay, from here is about the process-specific digital applications. First one is EMS. EMS provide the information about current plant energy consumptions and energy saving status. For example, we could easily compare the the daily and monthly easily energy consumption of total plant. So we can set the appropriate target for energy saving, so against the baseline from the previous operation. In addition, this software provide the performance and energy consumptions for each equipment so that we can list up, for example, we can list up all the pumps of the plant in terms of the energy consumption so that we can prioritize the pump in terms of performance and energy consumption so that the operators can easily decide which pump should be in the standby or need to be checked for further maintenance. It's about the membrane maintenance optimizer. This provides guide for when the CIP or the RO replacement is required. This MMO keep following the important RO performance parameters during the operations, and based on the previous result, this provide the prediction how these parameters will change in near future. In addition, it provides the simulation for RO membrane lifetimes and O&M cost also. It's about DCO. It suggests appropriate ferric dosing and pH for coagulation. Actually, the algorithms for DCO was developed and trained from the field operation data, so that at any given the seawater condition, it can suggest appropriate ferric dosing rate. This RAM tool about the prediction for plant availability and optimal overtime and maintenance cost during the entire plant lifetime. In order to do this kind of simulation, we constructed database for the failure rates and types for each equipment, as well as the repair time and cost. This database is the input for these simulations. And then with the considerations of plant process diagram, so we can calculate the plant availability. This is about the OTS. This OTS is virtual, the operator training systems. It generates the situation that can be happen in real plant so that the operators can be trained for such a situation. Okay, so these digital application I introduced are being implemented at Gijang SW Auto Plant in Korea. So in near future, so we can or we will present the more benefits achieved from this implementation. Okay, thank you.
Thank you, Dr. Shin. Now, next one, I'm inviting Dr. Eugene Rosenbaum from LG Chemicals. Now, he's going to talk about thin PM nanocomposite, what's going on reverse osmosis membrane. Let's welcome Dr. Rosenbaum.
Good morning. It's a great honor to be here in this forum and represent our company, LG Chem. In this short presentation, about 10 minutes, I will try to give you a very general and high-level overview of our company, what we are, and of course what we can offer to water treatment industry. And LG Group is a holding company that was founded more than 72 years ago, and today it employs over 220,000 people. It operates over 72 subsidiaries, mainly in three business domains: chemical, electronics, and telecommunications. We are, as LG Chem, one of these business domains, operate in 36 factories, 43 offices, and 4 R&D centers. As of today, we are almost 40,000 employees working for the company. Water solution business formerly belonged to the Advanced Materials Group, and this is a short history of our water business. We started back in 2005 with a startup called Nano H2O that was founded in California, based on the specific technology for production of RO membranes. After a short period of time, that for a few years the company started making the great progress in making RO membranes and achieved certain big sales in certain areas. In 2014, the company was acquired by LG Chem, and after commissioning the state-of-the-art production facility in Cheongju, Korea, with the support of state-of-the-art R&D center in Daejeon, the company has been growing in terms of sales with the double-digit numbers every year. This is the state-of-the-art manufacturing facility in Cheongju. We have fully integrated production, including casting, coating, rolling, and wet testing facilities. LG Chem R&D Center in Daejeon includes 5,300 researchers, PhDs, and of course there is a group dedicated specifically for RO membranes. As a company for the water business, we maintain a global network of our presence pretty much everywhere. Obviously, this is Korea, United States, Europe, Middle East, and so forth. So what is our core technology? What we can offer to the water treatment business? Of course, this is RO membranes, but what makes our RO membranes different from the others? This is a thin film nanocomposite membrane technology for producing these reverse osmosis membranes. The difference between our membranes and all others that are available on the market is the special nanomaterials that are included in the active layer of the membranes. These nanomaterials make the membranes more permeable for water without sacrificing the salt rejection. That makes some of the properties of our membranes outstanding among all other membranes available on the market. As of today, we can offer the full line of the seawater and brackish water reverse osmosis membranes. And I'm starting with this slide that shows the portfolio, the current portfolio of our products in seawater reverse osmosis membranes. We have a group of high rejection membranes that include 3 different models: SR, GR, and R, and energy saving membranes, ES. The high rejection membranes can offer you the highest salt rejection available on the market, 99.85%. All the membranes are available in two configurations, 400 and 440 square feet. This is for 8-inch models. Early this year, we launched the new generation of seawater reverse osmosis membranes. We call it SWG2. As of today, we have two models available. It's SR and GR. What makes it different from our previous generation is even higher rejection, 99.89%. There is nobody even getting close to that number. What it gives to the customers is the improved permeate quality without increasing operated cost and reduced energy cost without sacrificing the product quality. We can help operators save capital and operation costs for multi-pass reverse osmosis systems. This is a map of all the products available in the seawater market today. As you can see, those red circles are those that we're making. Even before the introduction of G2 membranes, we were basically above pretty much the whole market map. But with the introduction of G2 membranes, we pushed the bar even higher. Those that are marked with the dotted lines will be probably launched later this year or early next year. This strong portfolio in seawater desalination, seawater membranes make us very successful in installations for the past 2-3 years. And on this slide, you can see one of the few mega projects that we recently won and already installed and operating. This obviously mega projects in Saudi Arabia and Oman, as well as in Egypt, and there is a large project in China. The total portfolio of the recently contracted installations for the large projects over 100 MLD is about 1.4 billion liters per day, which is equivalent of the water supply for the population of the country like Belgium. Now we are moving to the brackish water reverse osmosis membranes. We've made a great deal of progress for the past 3-4 years in this direction, and as of today we can offer the full line of products in this segment. Particularly, we have 3 groups of membranes: high rejection, low pressure, and ultra low pressure. For the high rejection, as you can see on this slide, we offer 4 different models. This is super high rejection RG2, standard product R, high durability product Dura, R-Dura, and anti-fouling membrane AFR. Again, as the previous, this is for the 8-inch products, all of them available. The R and Dura are available in 400 and 440 square foot configuration, and anti-fouling is in 400 square foot. The rejection covered by these membranes vary from 99.6 for the standard product and up to 99.78 for the high rejection product, which is one of the highest available on the market today. The energy-saving low-pressure membranes are presented with our BWES model, and recently launched the modification with the low differential pressure spacer. We call it ESL. The product available on the market today offered in 2 configurations, 400 and 440 square feet, with a good rejection and flow. And finally, our latest addition to our brackish water portfolio is the ultra-low energy membrane, and that provides a good flow with a good salt rejection. Very good product for the applications that require low energy consumption. We also have the light commercial products available in the smaller diameters, 4-inch and 2.5 inches. I'm not going to talk about this much. They basically follow the general models of the brackish water in 8-inch configurations. As we have the installation, we have our presence in major facilities of the major players in the companies, and basically we are very strong in wastewater reuse, power generation, petrochemical refinery, and other industrial segments. Particularly, I would like to talk about a little bit about our recent installations for water reuse in California. We were able to secure installations in the very highly ranked major facilities in California for water reuse: Orange County Water District, West Basin, Scottsdale, and Silicon Valley purification facility. As a company, we provide full technical support from dealing with customers, from the getting the inquiry through the RO system projections, on-site membrane installation, startup and commissioning, data normalization, and if necessary, troubleshooting. We offer two types of software. One is for the designing system and running the projections. It is called Q+. It is available for free to download from our website. And another software is QC. It's normalization software. It is a unique software. It is web-based. It is very useful for our operators, for our clients. They can use it online, put all the data available on their facility, and immediately see the trends that can greatly help in operating their facilities. This is just a small portion of our installation, highlighting the one of those that are installed for the past several years. As you can see, we are very strong in certain areas, particularly here, and we hope that this short presentation would give you a good overview of our company and what we can offer to you to help in your business. Thank you very much. Any questions?
Thank you, Dr. Rosenbaum, for the extensive coverage of what's going on the electrochemical 10 PM nanocomposite reverse osmosis membrane. Now, I'd like to invite Mr. Unsoo Lee from POSCO Engineering Constructions. Can you come up here?
Good morning, everyone. I'm user manager POSCO ENC. I'm so glad to meet you. And thank you for giving me a chance to have a presentation about desalination technology, which was developed by our company in ID World Congress. Now, I'm going to get started. POSCO, our parent company, is the Steelworks of Korea, and it was founded for the first time in 1968. The Pohang Steelworks was built in 1981. The Gwangyang Steelworks was built in 1990, and they were privatized in 2000. The representative groups are POSCO ENC, POSCO International, POSCO Energy, and POSCO ICT. The total sale is 2017 is about $55 billion. POSCO ENC was founded in 1994. The POSCO has 52.8%, and PIF has 38% stake of our company. Our main businesses are plant, infra, and architecture. And the total sale is 2017 is about $6.4 billion. We have a major group network in Middle East, Asia, and America. I'm sorry. The main water and environmental business are water treatment, waste sludge treatment, and desalination. Next, I'm going to tell about the desalination project our company proceed. The project name is Gwangyang Desalination Plant Project. The located SNG plant site near Gwangyang Steelworks, POSCO. The capacity is 30,000 tons per day. This presentation This desalination project has a picture which uses warm discharge water, not just normal seawater. So also, although it's lower temperature in the winter, we can minimize high pressure operating RO system. The construction business expense is about $55 billion. If the turnkey construction work has proceeded for 20 months, and operation management is being proceeded for 30 years. As this whole schedule plan, we had started construction in 2013. We could minimize the construction period of thoroughly preparing, so we made a design period for 6 months. Construction period for 90 months. So this we had a test run and completed at the desalination plant July 2014. This is picture of a site. As you can see in the middle of the picture, there is a Guangyan Steelworks. Near Guangyan Steelworks, our desalination plant site is located. For water intake, as you can see in this picture, we intake a warm discharge waterway and discharge water concentration as the same waterway, which is located power plant. We designed the process like this condition. Final our product TDS has a range from 30–75. This is a layout. Guangyan desalination plant could minimize noise pollution when operator check RO system as a range RO system. High pressure pump and PX to different space. This is Guangyan process flow diagram of a desalination plant. We intake power discharge water. It goes through coagulation and procuration process, and it is conducted this first stage of primary treatment in top. After UF system, finally RO system. So as a result, we produce industrial water. There are pictures about Guangyan desalination process. The first intake facility our water distribution system. We intake a warm discharge waste waterway of EC power plant. We use three intake pump, and we have one spare pump just in case. We have minimized bubble generating, slow dilution, and leading for diffusion in water distribution system. We comply with discharge water quality standards. Next step. Now we are not running it, but using it only as a settling tank in Guangyan. UF membrane has from 0.1 to 0.01 micrometer per size, and remove SS and colloid. Next RO system. To meet TDS or product quality to 20 ppm, we consist of one pass to SWR system and two pass to BWR system. Especially, SWR system consists of ISD. Finally, energy recovery system in Guangyan desalination plant. It is applied PX, which is a rotary type of isovalve. In case of PX, it has a simple structure of high efficiency, and it has an advantage, which is for large capacity by a parallel connection. Especially, Guangyan desalination plant, UFR direct coupling technology was applied. Through this technology, we can reduce secondary condimentary in the tank, and we can make the system simple by removing storage tank and pump. Next, I would like to tell the content which we would development of desalination technology. If you look at the operation cost of existing desalination plant, power cost about for 42.6% of the total operation cost. You can see in the chart, but our power cost accounts for 83%, when the total power cost is 42.6%. Also, like our system, energy consumption has not been cut in spite of technology development since in 2005. Reverse osmosis system is a middle stage of technology. Even though we use high efficiency pump and energy recovery system, the energy reduction is limited only to 3.5 kilowatt hour per ton. So there is no more future stage. So to make energy consumption below 3.8 kilowatt hour per ton, the third generation hybrid technology is needed. The third generation hybrid technology is the next generation technology, which Apple, Fiero, and MD. Our company has been pushing for the development of Apple technology, which is one of the third generation hybrid technology. Our company pushed forward with a goal. The goal is to first introduce water through the development of Apollo hybrid technology for reuse of wastewater. The existing RO desalination technology needs a high pressure pump to produce fresh water from seawater. And in release RO construction of a high concentration into the ocean by recovery rate 50%. But if our hybrid technology is applied to desalination plant, we can decrease the amount of wastewater discharge in industrial complex through reusing of wastewater. The concentration can be reduced from the 32,000 ppm to 14,000 ppm due to seawater dilution through EPO process. According to this, we can produce industrial water. Like the same water quality as existing RO desalination one below pressure pump operation. Also, in existing RO desalination plant, high RO concentration, which is 60,000 ppm, is released to the ocean. On the other hand, RO hybrid technology can be minimize the impact, the coastal ecosystem with 30,000 ppm concentrate. We have started research and development as the topic, like development for design a power desalination system and operating technology. Pilot plant site is in Gwangyang, which is located the same waterway as Gwangyang desalination plant, a commercial plant. Need to use the reused wastewater of Gwangyang Steelworks. Pilot plant capacity is 119 per day. Fly Apple membrane type is a hollow fiber module. The hollow fiber module is a low pressure drop in the housing. So we can condense the system configuration with 2 stages. So as a result, we improve the recovery rate. I would like to tell about configuration of the pilot plant. Pre-treatment of wastewater is applied to MF system, and the UF system. But our main target of analysis of Apple powering is MMF. For UF system, it was not used alone. It was used as one-to-one blending with MF system. UF system has been applied as a pre-treatment process for seawater. Apple system has been configured in 2 stages for operation with a high recovery rate. The recovery rate we are talking about is the feeder is not low recovery rate. Therefore, the recovery rate is 1 stage is about 50%, and the 2 stage is 40%. So the total recovery rate is configured is increased to 70%. We have planned the mass balance. The capacity was 172 cubic meter per day at 10 degrees Celsius, and 194 cubic meter further at 23 degrees Celsius when pilot plant was operated. Actually, when you operated the pilot plant, water treatment was changed from the 10 degrees Celsius to 28 degrees Celsius, and operated average capacity was 188 cubic meter per day. MMF process was no use alone for the operating safety in the first step, including testing working. After when we operated MMF for itself, we couldn't see the decreasing product water according to the phenomenon of fouling. And we could see the product after fluctuating and to water temperature change. After April, we need the UF test. So we have a performance the operation of the UF system and MF system by blending them simultaneously as one to one. Today we have a short presentation time, so I'm showing the operating data till the late of June in this graph. The actually operating was operated until the end of September, and I will tell you about CIP and chemical cleaning if I get to the chance in the future. Next is the Apple recovery rate graph. We have a plant of mass balance that the recovery rate of 55% at 10 degrees Celsius and 67.2% at 23 degrees Celsius when fire plant was operated. Actually, operated average recovery rate was 65%. Next is dilution TDS. Every TDS was improved water was 31,800 ppm, and it was diluted at to 30,964 ppm. Okay, I can tell this presentation. Like seawater, wastewater TOC concentration is higher. It is difficult to remove by MF of UF system. In our system, water quality standard of influence quality is about 2-3 ppm. If wastewater and seawater was directly blended, TOC concentration was 3.81 ppm, and it was over the standard of influence water quality. So if Apple system is applied, TOC concentration could be low to 0.6 ppm.
Well, thank you, Mr. Unsoo Lee. Now, since time is very limited, from time to time, please watch me. Then I can give a sign, 1 minute left. I'd like to invite the last speaker, Mr. Jung-Kyu Jeon from Hyorim Industry Incorporated. He's talking about deep bed wastewater treatment for seawater desal plant.
First, thanks KDPA giving the chance to stand here. And first, I will introduce my company shortly, and then introduce titled system. My company name is Hyorim Industry, and we are a small and medium-sized business company which are design and manufacturing and installation for several kind of water treatment equipment. We established in 1968 and running over 30 years. We have one head office and one factory in Korea, and also we have one branch office in Philippines. There are 3 business fields in Hyorim. First one is public drinking water, which cover traveling water screen and inclined flight settler and underdrain system. Next one is sewage treatment part, which covers several kinds of sludge collector, including non-metal chain flight and circular clarifier. Final field is plant field. There are 2 parts in this field. First one is seawater intake, cover bath screen, traveling band screen, and drum screen. And then water and wastewater treatment part, which cover demi, potable water system, and desalination system, and also several kind of wastewater treatment system. Hyorim has over 90 employees, including engineering and manufacturing. We also have R&D center. Our recent research is that FO and RO hybrid process. This is our overseas reference list. There are over 20 references in seawater intake part and over 30 references in plant water and wastewater treatment part in Middle East. These are the list. I skip it. Hyorim got $100 million for sales amount in 2015. Showroom has two kind of ISO certificate and also have 4 kind of ASME stamp. This is the end of my company introduction, and next is system introduction. Before introduce the system, I want to let you know the background of this system. In case of wastewater at seawater desalination plant, there are high inlet TSS over 500 milligram per liter caused by high TSS at seawater intake, and also good saturable sludge caused from seawater intake, and poor saturable sludge caused from UF bagosh are mixed, and this makes hard to treat. And in case of Korea, small footprint and low energy consumption and constant TSS concentration toward the dehydrator and low effluent TSS are required. To treat this kind of wastewater, Shorin has developed the system named Deep Bed Wastewater Treatment System. This system is focused on that maintains stable operation and low outlet TSS than discharge regulation in Korea. There are 5 units in the system. First one is reaction tank. It is a coagulation and flocculation tank with a short HRT below 5 minutes. And next one is named CCAP. Sedimentation and concentration are conducted at warm basin with deep height, and also additional flocculation at pit well is conducted. Next one is named deep bed filter. It's a gravity sender filter with a deep media height using large ES media. And next one is dehydrator, mixing sludge cake having plus minus 78% water content using centrifugal type dehydrator. Final one is optional unit named decap, using when hard to dispose of sludge cake by high chloride concentration. Reducing chloride is in sludge by dilutions. CCAP and deep bed filter is a key unit of the system, so I will more detailed introduction behind. This is a PFD of the system. Wastewater is pumped from storage tank to reaction tank, and FeCl3 and polymer are injected and then moved to CCAP. And settled and concentrated sludge from CCAP are moved to dehydrator directly and disposed by sludge cake. And effluent from CCAP is moved to deep bed filter, and then filtered water are discharged. The backwash water from deep bed filter and dehydrated water from dehydrator are returned to storage tank. This is PFD with the decap option. The difference between previous PFD is that sludge from CCAP is moved to decap and then diluted and moved to dehydrator. The effluent from CCAP and decap are moved together deep bed filter. This is a detailed description for CCAP. There are efficient flocculation using mechanical mixing in reaction tank, plus water stream mixing in pit well. By the mixing in pit well, I can reduce HRT in reaction tank and also reduce the tank size. And sedimentation and concentration is designed as a separately in one basin by deep height. Upper part is for sedimentation and lower part is for concentration. And these features lead good sludge concentration and make process more simply. And also this deep height can cover high solid loading and secure sludge storage. And this lead stable interface between water and sludge. The sedimentation part and concentration part are divided radial vapor located at the end of the pit well. And this radial vapor can reduce impact caused by inlet flow, and this also can be helped to stable interface and maintain good effluent TSS. And these features lead that constant concentration to sludge can be extracted. These are key design factors of CCAP. The total HRT is about 3 to 5 hours, and sludge loading is below 20 kilogram per square meter a day. About total height is 6 meter, and extracted sludge concentration is 15 to 20,000 milligram per liter. These are some photos. And radial baffle is located around the middle of the tank. And by this radial baffle, sedimentation part and concentration part are divided totally. This is another key unit named deep bed filter from Denora Water Technology in USA. It is consisted with trough and filter media and gravel and air distribution and underdrain block named T-block and trench. There is deep bed height using coarse media. By this, water and air concurrent backwash is possible, and this leads low backwash water consumption. And it can cover high inlet TSS and maintain low outlet TSS. Also, it can cover bearing load of inlet TSS and high viscosity sludge caused by polymer injection in upstream. This is media. The media depth is about 1.8 to 2 meter and SG over 2.6 and UC below 1.4. And porosity is over 0.8 and ES is about 1.8 to 2 millimeter. By lower UC and high porosity, sludge can easily detach from media when backwash, even though high viscosity condition. And also there are no media loss during backwash by large ES and SG. The gravel layer using double tap design for preventing layer upset by backwash air. This is underdrain block named T-block. It is made HDPE and concrete. The blue color is HDPE and concrete is filled inside the block. By this picture, it has extremely robust and resistant to uplift by when backwash and suitable for seawater. It is very easy to install compared with other underdrain block. I just put it on the filter floor, and that's all. This is a photo of installation of the underdrain system. There are T-block laterals, and there are box head of air on the wall, and perforated air laterals are below the T-block laterals. And below the center line, there are trenches which collect filtered water and deliver backwash water. This is key design factor of deep bed filter. Filtration rate is about 1.5 to 200 meter per day, and sludge loading is a max 6 kilogram per square meter. And inlet TSS is up to 1.500 milligram per liter, and effluent to maintain below 10. The backwash water and air velocity is 0.2 and 1.5 meter per minute. And the backwash water consumption is less than 4 point. This is some photos of deep bed filter when filtration and backwash. We have applied this system at one of the seawater desalination plants in Korea, and we are learning very well keep the discharge regulation. Thank you very much.
I'm going to welcome any one comment, questions, if from the audience. Anyone? Yes.
Yes, I'm SK Hong from Korea University, and as a Korean, this is my comment, and also the hope. I like to see in the future the more closer relationship between KDPA and IDA. Thanks to Professor In Kim, I think he was very active as a president of KDPA, and the relationship between the KDPA and IDA was established on the basis of personal relationship rather than the level of organizations. And so I'd like to make a comment that in the long run, I mean in the future, the organizational level relationship or the collaboration between KDPA and IDA should be intensified and improved in the future. That is my hope and then comment. Thank you.
Thank you very much. Now, yes, I agree and I wish. And as you can see, Dr. Kurihara from Japan is sitting there. Now he is also from industrial area, has been affiliated with a long time. Now, Dr. Korea has just
Okay.
one more comment, please.
Dr. Professor S.K. Hon-san's comment is very nice, but we have to consider, even though this conference, I'm not agree. You know, many people together here, presentation done, nobody. Only Korea. Yesterday, only Chinese. After this, I explain APDA, probably no audience. So the planning of the headquarters of IDEA itself, the idea itself is very good. However, reality is no good. And big problem, KDPA and IDEA headquarters, if possible, next World Congress will be held in Busan, so much more intimate relationship will be happen. However, the Mombasa, Kenya, so it's kind of political establishment. Previous, I'm one of the site selection committee. And another point, we always visited China and the other countries, is how to organize the budget of the World Congress or local content. This is a big problem. No change at this moment in the headquarters of IDA. I think no somebody here. That means after the conference, you will get some profit. How to share this profit? Always big problem. Headquarters of IDA take everything back to Boston. And almost working, planning, reality done by local affiliate. So it's not dissolved yet. So I visited recently in China. Same thing happened now. So planning is always welcome. IDA, KDPA, joint conference like that. However, if we are discussing the profit, no good. So after this, I will present as APDA. APDA's budget, nothing. So up to the each affiliate, that kind of system we are doing. That's big problem. And even now, I'm still remained as one of board member, but that trend is not changed. That's if we are discussing, we have to overcome. This is
Thank you
similar,
very much,
same
Dr.
problem
Kurihara.
After this APDA, JDA.
Okay, thank you very much. Now, you have just expressed very pinching point of this IDA operations now. Even if I've been serving in the board of directors for many years, now I am stepping down, and maybe you can bring it out after coffee break to the Asia Pacific desalination. As you can see, the economy and the power is growing up in the Asian areas. Now probably give a little more comment, opinion to the headquarters of IDA, I hope. That's one of your responsibility as president of APDA, even if I'm stepping down. Well, thank you very much, you all, and you can take a coffee break. Thank you.